Thank you so much for your attention. The floor back to Eri to announce our next speaker. We have the honor to have Mr. Michail Bletsas for a second time in our events. Thank you so much, Mr. Bletsas. The floor to you, Eri.
It's my honor to present Mr. Michail Bletsas, who is a research scientist and the director of computing at MIT's Media Lab, where he has been working since 1996. He is responsible for all the infrastructure that the lab uses to produce, store, transport, and consume its bits. He was a member of the core technical and design team for the One Laptop per Child initiative. His current research interests include network security and wireless networks. Mr. Michail Bletsas?
Thank you very much for the introduction. When we are talking about cybersecurity, I think that the main determinant is a saying that came out a few years ago that went like, software will eat everything. What does that mean? We use more and more software control systems in our day-to-day lives, and that, from a cybersecurity perspective, means that the attack surface, the ways, the targets, and the ways by which these targets can be attacked always expands. This is pretty much a given. I don't think there is any way back from that trend. The attack surface will increase year after year from now on. And we have to learn how to live in an environment like that. As we are just coming out of the COVID pandemic, lots of things have changed in the ways we work. And one of the main principles of cybersecurity in the past used to be the perimeter defense, the standard perimeter defense. Cybersecurity takes its cues from physical security, from our previous experience, and big fences and moats with crocodiles in the past were a very nice way to defend a juicy target. Everything that was inside that perimeter was pretty much left to deal, to go on with its function or life, and everything that was outside need to be kept outside by the perimeter, by the moat, by the fence. This model was the premium, the main model by which corporations used to defend their networks, their digital assets, their data. And with a pandemic, with everybody working from home, that perimeter became became virtual, completely virtual. There is no real perimeter anymore. Very few corporations have all of their employees inside some kind of physical building. Less and less people are following that model, and that has very big security implications, because a lot of methods that used to be based on that are no longer valid. Give you an example from the place I work, MIT. We used to own network 18. So every IP address that started with 18 used to be MIT. That created some very easy perimeter defense rules for us. So everything that had an 18 address was allowed, and everything that didn't have an 18 address wasn't allowed. That worked for a very long time until we sold most of network 18 to Amazon, and we got some other networks. People started coming in more and more from their homes. So those simple rules just broke down. Apart from the perimeter defenses breaking down and not being a really good or current way of thinking about network security, we have various other developments. Code is increasingly governing the use of more and more appliances, devices, aspects of our everyday life. For example, cars are becoming hackable. The Internet of Things is putting more and more connected devices all over the place. And we have, it's very interesting to see the consumer attitudes in that respect. Consumers are very comfortable having microphones in their homes, cameras in their homes that record on their own and send the data to big data repositories in the cloud in exchange for some convenience. And there is definitely some issues there that hopefully will be addressed by changing some of these consumer attitudes. At least that's my personal opinion. I don't like that trend, but water is in the river, down the river, and it's very hard to return it, to turn the tide around. Another issue is the introduction of artificial intelligence, namely or more specifically in its use to create information, to manufacture information, to manufacture images. We all have seen deep fakes, and obviously to help with the social engineering aspect of network insecurity, of changing people's perceptions and attitudes. And the big thing is the fact that everybody is increasingly targeting mobile appliances. Our life is being governed and aided and facilitated sometimes by the mobile devices we'll carry around. And we have seen recently some examples of that and how much people are targeting those devices in Greece with the latest issues around surveillance of mobile phones. People are connecting things to the internet that they shouldn't really be connecting in increasing numbers. And that's a trend that should be reversed. There is a very famous recent case in Florida, where somebody connected the computer who controlled the flow of chemicals, of water treatment chemicals in the potable water supply of a town over there, in order to control it from home, and left it pretty open. Somebody found it who wasn't malicious and alerted the authorities, but on the other hand, somebody malicious could have found that and could have caused a very big issue by poisoning the water supply by pressing a few buttons from remotely. People are increasingly putting their faith in the cloud. In my opinion, that's only a stopgap solution, and it addresses the main concern that people have with the lack of expertise to deal with security issues, because you correctly assume that the big cloud operators have all the necessary people or have the necessary expertise to keep their systems safe and better set up than something that could be done in-house. So in that regard, the concentration of expertise and the access to that expertise that the cloud provides to its customers is a good thing for security. On the other hand, the cloud, with its concentration and centralization of data, presents a big juicy target to attackers. So it's a two-sided coin, and we have to keep in mind both sides, I think. One is the uh, offer of deep expertise, but on the other hand, that deep expertise is protecting an increasingly juicy target that, bad actors are going to be targeting. When it comes to bad actors in network insecurity, we see that they have become very, very professional, very, very, very good. And right now, hacking is being offered, black hacking, not hacking in the MIT sense, which is a good thing, but criminal hacking is being offered as a service, like everything else. The really good writers, the really capable writers of malware are offering their services to whoever wants to pay them to use them. So that vastly expands the number of bad actors. Also, recently, we have seen that they have become increasingly sophisticated in the way they attack. And one of the most concerning trends there was the software supply chain attacks, where they embed their malware in commonly used software that people use to run their operations. The SolarWinds incident was the most obvious one, but there have been many, many attacks there, and a lot of them that we don't know about. This is what worries me the most. Because it goes against the standard advice that we give to people, that you should be keeping your software current with security patches, etc., etc. Well, if your vendor is compromised, then you really have a big problem there, and it's very hard for most people to deal with that. Another trend that we see in the software network insecurity is that in the older days, let's say at the end of the previous millennium, the beginning of this one, the top level expertise, at least in the West, when it comes to network security, used to work for the state. The three-letter agencies in the US, and the Israelis were very well known for that. We all remember hacks like Stuxnet, or before that, the hack in the Greek mobile phone switches in the early 2000s, that were carried by state-sponsored actors. States, though, cannot pay these people as well as the private sector can do. And a lot of people are migrating to the private sector now. We see that all these very, very sophisticated hacks that people use to get into mobile phones, like the Predator, or before that, the NSO software from Israel, came from people that used to work for state agencies and then figure out that they can make a lot more money in the private sector. We had issues in the US too, where hacking tools used by the NSA were leaked after people left, probably that employment, and they were used by other bad actors to build tools of their own. How is the situation hopeless? No, the situation is not hopeless, because human errors are still the top cause of network security breaches, and more training and better training can definitely go a long way there in making us safer. And there are technological solutions. We see that when it comes to networks, we see the zero trust principles being applied, where we essentially are doing a lot more fine-grained analysis of the needs of hosts and people to communicate with each other, and only allow the communications that are absolutely necessary and nothing else. So we treat everything like a non-trusted entity, which is probably the way to go. We shouldn't assign more trust to devices and hosts and software systems more than what is absolutely needed to do their function, to carry out their intent function, which is not how we used to operate up until now. And AI, which creates some problem, also can help, because for the first time we have the ability to recognize attacks that we haven't seen before using machine learning. So AI will be a big help there. At the end of the day, though, it's not about making sure that we never get hacked. Like biological, we should take our cues from biology again. And in our human body, we have a lot of pathogens, and we know how to deal with them. We are never pathogen free, and we will never be pathogen free in most networks. There are exceptions where we should be absolutely completely pathogen free, control systems of big infrastructure plants, for example. But for everybody else, we have to learn to live with pathogens. We have to learn to live by hiking. And the important thing is to be resilient and to be able to quickly recover from those attacks. And that is a lot more important than actually making sure that we'll never get attacked, because we will get attacked at some point. If I'm allowed to draw an equivalent, we should see what happened in the West. We should compare what happened to the West with COVID, with what is happening in China and their zero COVID policy. It doesn't work. So resiliency is more important, and that is what we should be focusing most of our attention: resilience and education. Thank you very much.
Mr. Michail Bletsas, thank you once more for being with us. It was an honor, as always. And we may now proceed to the panel discussions. Please join the next session, Why Digital Trust Matters for a Democratic Society and the Digital Economy.